In this video, I want to have a look at the fundamental theorem of calculus. So the fundamental theorem of calculus says that if we let f of x, so capital F of x, be a primitive function of little f of x, then the integral from a to b of f of x is going to be f of b minus f of a. So what that means is we're going to find the primitive function, and then we're going to substitute b in and a in and subtract them. So a few terms there, f of x, so that function that we're given, is called the integrand, and the a and the b are called our lower and upper bounds. Just to clarify that again, what the fundamental theorem of calculus means is that we can evaluate a definite integral by first finding the primitive function, then substituting in our bounds and subtracting. So the idea of this is that integration is actually the opposite of differentiation, which you're quite comfortable with by now. So that's all going to make a little bit more sense when we actually go through and do a few examples. So I've written our little fundamental theorem up here to help us. And our questions ask us to evaluate the following definite integrals. So our first one is integral from 1 to 5 of 6x dx. So that means with respect to x. Before we start this, if you do need a refresher of how to find primitive functions, there is a video that we did earlier towards the end of our differentiation topic that you can go back and revise if you'd like to. But we are going to go through about 5 examples in this video as well. Alright, so to integrate this, so to evaluate this integral, the first thing we're going to do, we're going to draw big square brackets. We're going to find the primitive function of this. So that's going to give us 6x squared, because we'll increase the power, and then we'll divide by that new power. And then we're going to write our bounds just outside those square brackets. So now we're going to simplify that expression there. So that's going to give us 3x squared. And we'll still have our bounds on the outside there. So now we've found the primitive function. Now we're going to substitute in our upper and our lower bounds and subtract. So it's upper bound first. We'll go 3 times 5 squared minus 3 times 1 squared. Should give us 3 times 25 is 75. Minus 3 times 1 is 3. Would give us an answer of 72. The second example has a few more terms in it, but it's going to be the same process. So to evaluate that integral, we'll draw a big square brackets. We're going to go through and find the primitive of each term individually. So this one will give us 2x cubed, because we'll increase the power, divided by 3, minus 5x squared divided by 2, plus 4x. We'll close our square brackets off and put our upper and lower bounds in. Now that one's not really going to simplify, so I'm going to jump straight in and substitute. So we're going to have 2 times 3 cubed over 3. So this is substituting the 3 into everywhere. So minus 5 times 3 squared over 2 plus 4 times 3. So that's substituting the 3 in. Then we'll go minus and we'll substitute the 0 in. So we'd have 2 times 0 cubed over 3 minus 5 times 0 squared over 2 plus 4 times 0. Now that whole thing, because every term has a times 0 in there, that whole thing actually just becomes a 0. But we'll go through and evaluate this one, and if you pop all of that in your calculator, you're going to get 7.5, or you could write it as 15 over 2. Our third example has bounds 1 to 4, and our function is x minus 4, x minus 5. So before we even start finding a primitive function, what we're going to do with this one is expand out those brackets. So we're still going to have our integral from 1 to 4, and we're going to expand this out. So x times x would give us x squared. Then we'd have minus 5x and minus 4x, so minus 9x. And minus 4 times minus 5 would give us plus 20. Right, so we've still got the same question, we've just expanded it out. And now we can find the primitive function. So we'd have x cubed over 3 minus 9x squared over 2 plus 20x with our bounds of 4 and 1. So now substituting in the 4, we'd have 4 cubed over 3 minus 9 times 4 squared over 2 plus 20 times 4. And we're going to minus, and we'll substitute the 1 in everywhere. So 1 cubed over 3 minus 9 times 1 squared over 2 plus 20 times 1. And if you pop all of that in your calculator, just being really careful to get all your fractions and all your powers on the right things, we would end up with 27 over 2, or you could write it as 13.5. Our next example has the integral from minus 2 to 2 of x to the 5 plus 8x squared all over x squared with respect to x. So this is looking like a bit of a mess right now, but what we can do if we get a question like this is that we can split it into different fractions. So splitting it to x to the power of 5 over x squared plus 8x squared over x squared. So instead of writing it as one whole big fraction, we're going to split it into smaller ones. So again, we're not even finding the primitive yet. We're just going to rearrange this expression. So we'd split it into two fractions, and then we can simplify it down. So x to the power of 5 over x squared would give us x cubed, and the 8x squared over x squared would just give us 8. So now we can find the primitive function. So we're going to have x to the power of 4 over 4 plus 8x with bounds of 2 to minus 2. Then substituting in, we're going to have 2 to the power of 4 over 4 plus 8 times 2 minus 2 to the power of 4 over 4 plus 8 times minus 2. So again, being really careful that you're getting brackets all in the right spot. You might want to do these as two separate calculations, so if you're going to get confused with all your brackets. But that will come out to be a really clean 32. And our last example is the integral from 1 to 2 of 1 on x to the power of 6. So what we're going to do with questions like this is we're going to rewrite it first to have a negative index. So we'd have x to the power of minus 6 dx. So now we can find the primitive function. So just be really, really careful here. When we find the primitive, we increase that power by 1. And this is where a lot of people trip up, is that increasing minus 6 by 1 will take you to minus 5, not just minus 7. So we'll divide by minus 5 then. And we've got our bounds of 2 to 1. Then we can substitute in. So we'd have 2 to the power of minus 5 over minus 5 minus 1 to the power of minus 5 over minus 5. And if we pop that in the calculator, being really careful of all your negatives and your negative powers, you'd end up with 31 over 160. So let's have a look at the fundamental theorem of calculus and how we can use it to evaluate definite integrals.